Hi, everybody. Thank you for coming to my session today. And I'm going to speak about the Cosmos DB with you today. Before I get started, let me speak about myself. My name is Hasan Savran, and I'm a Microsoft Data Platform MVP. This is my third year. And I'm from Cleveland, United States. Currently, I'm a business intelligence manager at one of the large insurance companies here. I have a great knowledge and experience with the web development and data. And if you will have any questions that I might not be able to answer today, please reach me from the LinkedIn or Twitter. I will be more than happy to help you in answering any of your questions you might have. So let me actually jump in to our presentation, and let me actually give you the video of Azure. The picture, but the video. As you can see, you are actually seeing the blue ones here are the data centers that most of us really care. But there's much more than that out there going on with the Azure. Good news is we are actually going to have 17 new data centers coming up to Azure. There is going to be 3 for America. 1 is going to be for United States, 2 for Latin America. There is going to be 7 actually coming up for Europe. There will be 2 for Middle East and 5 for Asia. The reason I'm calling this because, just like any other features of Azure, when Azure grows, all of the features grows, and Cosmos DB grows. Cosmos DB actually born in this structure, and programmers really concerned about the Azure, and when Azure grows, Cosmos DB grows with that. And it always, it doesn't matter which feature you are really trying to use in Azure. Always they say that, try to put the feature close to your user. With adding 17 new data centers, we are going to be actually closer to our users, especially, important for Cosmos DB. Before I change this, I just want to actually add one more thing here. Your user is actually come from web application or some kind of application to your Azure, to Cosmos DB. So don't forget to put those servers in the same region, so the latency between those servers will be the minimum. All right, so let's actually start to talk about the partitions. Partitions are really important, and if you are using the Cosmos DB, you should know how partitions work. There are 2 types of partitions in Cosmos DB. The first one is the physical partitions. Physical partitions are maintained by Microsoft totally, and you cannot change any settings on them. But that doesn't mean that you should just ignore them. You should actually know 2 numbers about the physical partitions by your heart. The first one is 50 gig. So a physical partition is really, whenever you create a database, I'm just kind of representing here as a container ship. Whenever you create a database, Cosmos DB gives you this empty container ship. That is your physical partition. And its capacity is 50 gig. So if your data is going to, go 60 or 55 gig, Cosmos DB is just going to give you another container ship. So you should know that whenever you hit the 50 gig, you are going to end up with a new physical partition. The next one you should know is 10,000 request units. And that's how, the horsepower of your container ship. So for whatever reason, you might have 20 gig data, but your application might be really busy, and you might need more than 10,000 request units. So if you're going to, for example, put 15,000 request units, you're going to end up with 2 physical partitions, even you have less data than 50 gig. So those are 2 really important numbers you should know. You cannot change anything in physical partitions, as I say. And the other thing you should know about the physical partitions, whenever you create the data is getting saved in the local SSD drives of your service. So if we will actually go and look at a little bit more deeper than this, what does physical partition look like? A physical partition is a replica set. If you put the technical term to the side, you have 4 computers, and you have 1 leader, 3 followers. Leader is actually taking care of all the updates, deletes, insert. If something needs to change, it goes into the leader. Then leader actually moves that to the followers. So this model actually is good without any kind of global distribution. So if you are in one region and you don't have any other regions, this is your model. This kind of tells you why Cosmos DB is very, fast database. Because if you, for example, you have a web application, potentially you have 4 places to actually go get that data. Not just one, but you have 4. And that's only one physical partition. If you are going to have a global distribution, then this model changes a little bit. What's going to actually happen here is one of the followers is going to actually become a forwarder. So whenever an update comes up from the web application or any kind of application to the, for example, region 1, it's going to go in leader. Leader is going to push that to the followers and the forwarder. As soon as forwarder is going to get that, it's going to actually move to the other region's leaders. That's how actually the data is going to get synced up in the backend in Cosmos DB. So as I said before, physical partitions are important and you should watch them. To watch them, actually, we have a monitoring tool here that you can go in Azure portal in Cosmos DB. As you can see here, let me find my pointer. We are in here, Azure. Under the monitoring, you go to the metrics. And from here, you are going to pick the storage. Then you need to select your database and containers. As soon as you pick those container, whichever you want to see, all those graphs will be populated. And what is important here is this graph here. This one tells you that you have 3 physical partitions. And when you pick one in here, actually, the user picked this one. That's why the color is kind of darker here. And this one actually tells you which partition keys are actually large in this partition. So you should watch this closely. Maybe not daily, but you should come to this page and check monthly or weekly at least and see how your partitions are doing. They should be close to each other. I'm not saying they should be perfectly matched. That's never going to happen, but they should be kind of close to each other. And if you have one big one here and the other ones are smaller, that means you are having some hot partitioning problems, and you should try to fix that problem before it comes and actually, becomes a bigger problem. So this page is important, and be sure that you are using this page and kind of monitoring your physical partitions is important. Next is logical partitions. Now, logical partitions, we are totally in control of them. So partition ID or the partition key really distributes all your requests, because if you put the partition key in your where clause, Cosmos DB is going to know exactly where to go and get that data. Also, it distributes to storage. As I showed you before, it's going to actually start to save the data in the same area with the same partition key. So you want to be sure that partition key is almost kind of like equal to each other as size-wise. And also, it's intelligently route the queries for efficiency, which means that again, if you have the partition key in your where clause, Cosmos DB will easily find that. It will be faster. Also, it will be cheaper for you. So if we actually talk about more, I guess, the logical partitions almost like you are really organizing the data. So like anything in the life, if something is organized, you will actually find what you are looking for easier and faster. That applies to data too. So if we actually, I guess, let's talk about, for example, relational database SQL Server. How is this partitioning working versus Cosmos DB? Usually in SQL Server, you are the dev, you create your tables, and you give them to DBA, and DBA push them to your production. So everything works fine because there's no data in them. This is the first time the data is coming in. So probably you are going to be fine maybe next 6-8 months. After 6-8 months, the queries are going to start to slow down, and you are going to say, well, what's really happening? Everything was great. Now what? You send your project manager to DBA. DBA looks at it and says, well, it looks like you need some indexes in these columns. So he's going to create the indexes. Everything's going to go back to normal. Everything's going to be, fast and happy. Well, that's going to go maybe another 2-3 years like that. Then it might start to, slow down again. Then you're going to go and tell your project manager will go to the DBA, and DBA is going to look at it and say that, you know what, I think it's time to actually create some partitions for you because you have too much data. So that is the workflow in SQL Server. It's kind of like, don't touch it before it, if it's not broken, don't touch it. So it's some kind of idea like that. In Cosmos DB, it doesn't work like that. In Cosmos DB, actually, you have to create your partition in the beginning, not at the end. That's a good way to kind of, I guess, fix problems, so you don't have to wait 2 or 3 years. But the problem is, usually you need to find the partition key when you don't even have data in your container. So you really need to know your data. You want to be sure that whatever you're going to pick the partition key, you don't do that randomly. You do it. You always want to be sure that that partition key is always going to be in your where clause, because you want to always use that. If you use the partition key, things going to be faster. More importantly, it's going to be cheaper for you. Also, you want to be, check your application. Is it going to be a write-heavy application or is it going to be read-heavy application? If it's going to be write-heavy, you want to use your partition key. You want to make it as unique as you can make it, because since you are not going to update anything, you're just going to always write. You want to be sure that your partition key is very unique. If it's read-heavy, you want to be sure that that partition key always going to be in your where clauses, so you can make your queries cheaper and faster. So those are the 2 things you really need to pay attention. And if you need to spend time on it, please spend time on it, because that's really the first curve you are going to take in Cosmos DB, I guess, race. So if we actually put those together, now we have a containership, empty containership, which is the physical partition. Then we have the small containers, which are the logical partitions, which you define. So there are many ways to group your data, right? So for example, if we are creating an IoT application for a car and we are trying to write and read data to a car, well, you can group that data many ways in this containership. You can do maybe by model, you can do by year, you can do by color, you can do it anyway. But you want to be sure that if you, for example, let's say you pick the year, right? The problem with the year is then this year you might have 100,000 cars built. But maybe next year people are going to love your product and they're going to, sell 1 million. Now you have a big problem, because one container, you have one big container in the ship and you put 10,000 cars in it. And you try to read and write. So what's going to happen here is if you're try to write, read the data, you're going to put the partition key, I don't know, model, let's say 9.0. Well, this is not really that useful for Cosmos DB, because it's going to go open this big container and it's going to find 100,000 cars in it. And then it's going to try to find the car that you want to update or read the data from. It makes more sense to actually put one car in each containers. So if Cosmos DB knows the car, probably we are going to go with the VIN number, vehicle identification number. If you pass that in your query, it's going to be much easier for Cosmos DB to actually go find which physical partition that data is in and which logical partition is in. So it's going to open that container. The data is going to be there. The car is going to be there. You can just update, read, and be done with it. Also, another number that you should know by heart with the logical partition is 20 gig. That is the largest a logical partition can be. So other thing to kind of know, don't think that, okay, if I actually hit the 20 gig, I can repartition. You cannot repartition a container. You have to create a whole new container with different partition key and move your data from the old one to the new one. So as I said before, it's very important that you spend your time and find a good partition key for your application. All right, so I'm going to actually go back to physical partition here, because usually this happens and it comes like almost like from nowhere for many people. So let's say we are having this application and we have a request units for 9,000 request units per second, right? So we have one container ship, which is the one physical partition, and we fill it up, let's say, 30, 40 gig, and we are good, right? But for whatever reason, maybe our application got busier, or maybe tomorrow is Black Friday. We want to be sure that we are always going to be, on, and it's not going to send all those 429 errors because you don't have enough request units. You say, well, you know what? I just want to be safe, and I'm going to actually move this to 12,000 just to be sure. So maybe later I can just scale down. As soon as you make this 12,000, you know what's going to happen. There were two numbers that you should know by heart, right? And that was the request unit, 10,000. That means you are creating a whole new physical partition. Now you have two containership, but you still have 12,000. The second containership that we just created, it needs some resource to run, right? So now you are dividing your 12,000 to two. So one of them is going to have 6,000, other one is going to be 6,000. If your logical partition key, if you pick the good one, that shouldn't be a problem, because what Cosmos DB is going to do here is going to actually start to move some of the containers from the first one to the second one to balance things. But if you have a huge container in the first ship, and which might, requires 4,000 or 5,000 requests just for itself, now actually you are in trouble, because the first physical partition here might start to actually give you more problems, because it used to have 9,000, now it has 6,000. So that's why it's pretty important for you to actually pick the right partition key, and also know those numbers. Whenever you actually create this new physical partitions, you should go back that monitoring tool and be sure that everything is balanced. And in this case, we were trying to fix the problem, but we might actually cause more problem, because maybe we are having some hot partitioning problem here. All right, so let's see what actually Cosmos DB looks like on paper, right? So you go to Azure and you create the service. Creating the service is pretty easy, just like many other service. You just pick the subscription, you pick the name for it, and you have the Cosmos DB. Then you're going to create your first database. When you create the first database, well, you're going to have some options here. So first of all, you're going to pick the API. How are you going to actually access your data? What language are you going to use? The first one is the SQL API. SQL API, I will suggest you to SQL API if this is your first application, or this is an application you are starting from scratch. Then I will go with SQL API, because Microsoft is in charge of SQL API, and most of the new features go in SQL API. And I will suggest that if that's a new application. But rather than SQL API, you still have Mongo API, Cassandra API, Gremlin API, and Table API. So, for example, if you have a MongoDB and you already have API for it, your developers have been writing for 2 or 3 years, but you are kind of tired of managing the MongoDB. You want to just maybe give that to Microsoft in Cosmos DB. In that case, you can just pick the MongoDB. From there, you're going to move your data from your MongoDB to Cosmos DB. All you have to do is, with your code, you're going to change your connection string. Then your Mongo application is going to actually think that is accessing the MongoDB when it's accessing the Cosmos DB. And that applies to Gremlin, that applies to Cassandra, and that applies to Table API. After you pick your API, you are going to be ready to actually create your container. When you create the container, depending which API you pick here, the naming might be a little bit different. For example, SQL, we call the data or the data in documents. If you pick Gremlin, your data is going to be nodes and edges. If you pick Table, that's going to be rows. So that's mostly applying if you are especially using the REST API, but the naming might be a little bit different when it comes to containers, depending which API actually you pick. Also, each container is going to have items in it. The first one, we have store procedures. Store procedures are good for writing data, not for reading data. If you think about the replica set I actually showed you earlier, you have a leader and 3 followers. Store procedures are always executed on leader. They will never execute it on the followers. That makes them better to write data, not to read data. You don't want leader to read data when it's busy with all the operations coming in. So if you are using store procedures, please don't read data with them. Also, if you didn't know it, you have to know JavaScript, because store procedures are in JavaScript. Second one is the user-defined functions. These are a great way to express complex business logic in your queries. They are useful. and those can actually run in the followers. So I will suggest to not use user-defined functions, especially in the where clause, as only one filter. Add something else on it, because just like in other databases, if you are going to use a function in where clause, you are not going to be able to use, or Cosmos DB is not going to be able to use any indexes on it. So it's going to cost you much more. So rather than just using the user-defined function as in where filter, try to add more. Be sure that, if you can, partition key should be there, or another kind of filters you can use. Triggers are a little bit different too. We have two types of triggers: pre-triggers and post-triggers. And those will be has to be triggered by you manually. They won't get triggered automatically like SQL Server. We have merge procedures and conflict. Those are going hand by hand. And what's really happening here is, when you have many regions, conflicts happen, right? You might have one user try to write the data from United States. Other user might be maybe try to change the same data from Europe. So how that conflict happens, what's going to happen? So what you do in that case is you create a store procedure, which is going to have all that business logic whenever, situation happens like that, which data you are going to trust. You're going to put all your logic in it. You are going to actually save it as a merge procedure. Then what's going to happen is when a conflict happens like that, it's going to go in a queue. Then that merge procedure is going to run for each conflict and actually fix the problems one by one. So that's how the conflicts actually gets fixed in the backend. All right, next, storage. How does Cosmos DB store the data? There are two types of storages in Cosmos DB. The first one, you have the application, and it's using all the APIs to write the data to Cosmos DB, and those are written as a row store. So since we don't have rows, we have documents. I put them document by document, right? So usually whenever your application goes to Cosmos DB, it's transactional storage. This is operational database. And usually you are not trying to analyze data here, right? So if you are, for example, looking for a product, you give the product ID and you get all the data about the product. You are not trying to write a report here. So as long as that is the case, Cosmos DB is happy, you are happy, everything should be fine. But if you have data scientists, you have analytics, you have reports, and you want to actually read the data from Cosmos DB, you don't want to do that in an operational database, right? You don't do that in SQL Server. Don't do it in Cosmos DB either. To actually do that, you need a whole different environment. So it will be much cheaper or easier for you to actually read data from there rather than operational database. So to do that, you can enable the Azure Snaps link. Whenever you go to your data area, you will see that button out there. As soon as you turn that on, Cosmos DB is going to actually start to move that data from transactional storage to analytical storage. Your data is going to actually save here differently. It's going to be column store. So we are going to actually save column by column rather than row by row. In that case, for example, if you have a property name age and you want to find the average of age, all the ages are going to be same in the same area. So it's going to be much easier for your application to actually analyze the data and find the average much faster that way. To actually get the data, you have to use the Snaps Spark or Snaps SQL. So you can use any of those. This one actually gives you isolation between operational and non-operational. So it's a great option. And usually if you have the SQL Server, you kind of handle this by ETL. You just take it from the OLTP to reporting to analyze. I don't know how many environments you have. But in here, actually, Cosmos DB is going to handle that for you. And you don't need to worry about ETL. It's going to break one day and I have to go and fix it. So, and also it's almost like real-time analytics, right? The changes, it really depends how much data you have in operational database. But usually I see the changes in analytical storage in 30 seconds. So it's very, very quick. All right, next. So this is actually on paper. As you can see, the yellows are the current data centers and the orange ones are upcoming data centers. So whenever I actually talk about Cosmos DB, we always talk about these big projects and those big companies, they are using it. But really, Cosmos DB is not only for the big companies. There are many industries can use Cosmos DB. For example, airlines, they are, selling tickets, price changes. There are special days that, you want to scale up and scale down because people want to, go and get the ticket in special those days because they want to travel. Healthcare, it doesn't matter. You're a large, healthcare, a hospital. You can be a small with a couple of branches, but what you are looking from a database is really, you want a stable database, you want an available database, and you want a fast database. Especially in these days with, COVID is going on, the last thing you want to do as a healthcare IT is actually go and upgrade your database. So cases like that, Cosmos DB shines. And, rather than healthcare, we have, for example, education. Education right now, all the students are, working from home, and Cosmos DB born online. So really, there are many other industries here which can use Cosmos DB. You don't have to be like the top 10 biggest company here. Food is the other one, and really, your users are everywhere. Everybody needs some food, and in these days, all the restaurants were closed, so you had to sell it online. So as you can see, just any other industries are good. So if you're a small industry, Cosmos DB has the free tier. So it might be even free for your small businesses. And the last thing I'm gonna suggest you is one more thing. Don't let people scare you because you want to save your data in JSON, unstructured JSON, because that's the first thing they will probably say if you want to use the Cosmos DB. If you survive with 40, 50 tables, you can survive with JSON with no problem. So I think I'm almost out of my time here. I hope everybody learned something. As I said before, if I cannot answer your question